Hi, we're doing more exponential functions here, and as you can see that we have an equation that we're asked to write which shows the relationship between the population and the number of decades after 1900. We're asked to define our variables, and then it asks us to find out when the population is going to reach 1 million. So what we're going to do is we're going to start off by locating what our x and our y variables are. So the x coordinates are always this first column. Y is always my second column. So we're going to start off there. So the decades after 1900 is the x coordinates, and the y is a population in tens of thousands, or 10,000s. So next thing I have to do is come up with an equation for this. So we do see that this is increasing by 1 every single time, which is good. It helps us. And then we're going to look at what's going on in this part of the problem right here. So if I'm looking at this, this is going from this to this to this. It's getting rapidly bigger. So if I'm not 100% sure, because this is a decimal, sometimes people have a hard time with these types of things. What we can do is take any, since this is consistent, we can go ahead and take any of these numbers and then divide by the number previous to it. So I'm just going to start with 4.5, and I'm going to divide it by 1.5, which is the number right before it. So you can see I did this number divided by this number, we get 3. That's going to work with every single one of them. If I do 13.5 divided by 4, it'll get 3. And if I do 40.5 divided by 13.5, I'll still get 3. So my growth factor in this case is going to be times 3 on every single one of these. And so when I go to write my equation, I want to be able to know what I'm starting with. Now, I don't start at 0. I start at 1. So I have to kind of go backwards. So if I want to go back 1 year, I'm going to subtract 1 to get to the previous year of 0. I have to do the opposite of what I was doing here. So I have to, instead of adding, I subtract. Now here, I would multiplying, so opposite of that would be to divide by 3. So I'm going to take 1.5, and I will divide it by my growth factor, which is 3, and get my starting value, which is a half, 0.5. So my equation for this would be y equals, or f of x equals, my starting value, which is 0.5, and then times my growth rate, which was 3, to the x coordinate, exponent. Now we're asked for reaching the first time we reach 1 million. So what I'm going to do is, in the next video, I'm going to show you how to do that. So if you want to know how to do the calculation for that, you can look for the part 2 of this. If you like, share, and follow for more at YouWantAlgebra, located on my YouTube, my Instagram, and my TikTok. And I look forward to helping you more with exponents.